Hey everybody, so let's start out on page 228, and what we have is negative 1/2 p is greater than or equal to positive 3. So we have a fractional coefficient, we have a negative, so we got a couple things going on here. So remember, to isolate the variable, we multiply by the reciprocal, right? So to get rid of the negative 1/2, we're going to multiply by the reciprocal of 1/2, which is 2/1, right? But we need to multiply by a negative 2/1 or a negative 2 because negative times a negative is a positive, and we want to leave p as a positive. But if we multiply by negative 2 on the left side of the inequality, we need to multiply by negative 2 on the right side of the inequality. And of course, because we're multiplying by a negative, we at this point need to flip the inequality, okay? Because we're multiplying by a negative. So we need to flip the inequality. So at this point, now we have positive p is less than or equal to negative 6. So now let's try that out so this is our solution set, right? These are the possible values for p. So if I go back and I have negative 1/2 p was greater than or equal to 3. Now let's go ahead. We have to find a value for p. P is less than negative 6. So let's go ahead and plug in negative 5/1 and see if this works. So we're going to put in negative 5 for the value and see if this works. So negative 1/2 times negative 5. So you get a negative times a negative is a positive. So it becomes 5 halves. And of course, 5 halves is greater than 3. So I know when I substitute here that I did it correctly. Let's try another substitution. Let's substitute because we want p to be less than or equal to negative 6. So less than or equal to negative 6. So let's go with negative 1/2 less than negative 6. So let's go with negative 7, right? Because negative 7 is less than negative 6. So negative times a negative is a positive. 7 halves. 7 halves is actually what? 3.5, right? 3.5 is greater than or equal to 3. So I know negative 7, when I plugged it in for the value for p, works. Let's try, because it says it could be equal to negative 6. Let's go ahead and plug in negative 6 and see what happens. Negative times a negative is a positive, and 1/2 of 6 is 3. So of course 3 is less than or equal to Sorry about that. I had a phone call. I don't know if you guys heard that on the video or not. I had plugged in the value of negative 6 just because this was p could be less than or equal to negative 6, and that still made the solution set, or it made the inequality true. So remember, when you are multiplying or dividing by a negative, you flip the inequality sign for the solution set. But then when you plug in the values, you use the original inequality. So I'll just do one more. Let's just say, all right, I need p has to be less than or equal to negative 6. So let's try negative 8, right? So 1/2 times negative 8, right? Because I'm not negative 1/2. I'm substituting negative 8 for p because negative 8 is less than negative 6. And then I go back to how my inequality was originally facing, 3. So negative times a negative is a positive. 8 times 1/2, well, it's 4. So 4 is greater than 3. So I know that I've done this one correctly, okay? So let's go over here And now I'm on page 220. Negative 1/5 W is less than or equal to 2. So again, we've got a fractional coefficient. We know we're going to be multiplying by a negative. So as soon as with an inequality, as soon as I see a negative that I'm going to be multiplying by or dividing by, I have to be thinking in my head, I need to flip that inequality for my solution set. So I'm trying to isolate the variable, so I'm going to multiply by the reciprocal, right, of negative 1/5. So the reciprocal of negative 1/5 is negative 5/1. So if I multiply by negative 5 on the left of the inequality, I need to multiply by negative 5 on the right. So now a negative times a negative is a positive, so I have positive W. I need to flip my inequality for my solution set because I've multiplied by a negative. So W is greater than or equal to negative 10, right? Because negative 5 times positive 2. So negative times a positive is a negative. 5 times 2 is 10, so negative 10. So for my solution set, remember, this is my solution set. This tells me possible values for the variable that would make the inequality true. So we are going to be looking for values for W that are greater than or equal to negative 10. So I'm going to rewrite my original inequality here because that's when I'm plugging my values for W in. So let's say negative 1/5, and I'm going to pick a value that's greater than negative 10. I'm going to say negative 8, right? Because negative 8 is closer to 0. It's greater than negative 10. And we're just going to multiply across. So positive, negative times a negative is a positive. And I have 8/5, and 8/5 is less than 2, right? Because it's 1 3/5. So I know that that one worked correctly. Let's try another value for it. Let's try a positive. So W has to be greater than negative 10. So let's just say negative 1/5 times, let's just say 5, right? Because positive 5 is greater than negative 10. And it should work out where we have a negative times a positive is a negative 5/5. So this is actually negative 1. And this is true, right? Negative 1 is less than negative 2. So I know that I did this correctly. Now it says W can be less than or equal to negative 10. So now let's try this with the value being negative 10, right? Because we have that equal to sign there. So let's go ahead and try it with negative 10. So going back to my original, negative 1/5 times negative 10 is less than or equal to positive 2. So negative times a negative is a positive. 10/5 is what we get. 10/5 is 2, and 2 is less than or equal to 2. So we know that we did this correctly. So the takeaway is when you're multiplying or dividing by a negative, when you're solving for the solution set, you flip the inequality. When you're testing your solution, your possible values for W, you plug it in with the original inequality. Last thing that I want to remind you is graphing these. So P is less than or equal to negative 6. So if I'm going to graph that, P is less than or equal to negative 6. So with a negative, I'm going to say, all right, negative 6. So let me give another one over on the other side. Negative 5, negative 6, negative 7, and negative 8, right? We want to, and I think I had said use 5 points. Let's make one more. Sorry, that's messy. Negative. So remember when we're writing on a number line, it's getting more negative as we move this direction. So P is above negative 6. Remember, it's equals to less than or equal to, so we're going to fill in our dot there. And P is less than or equal to negative 6. So the less than direction is this way. And again, our trick works with the pointer. Our back of our alligator is pointing in the direction of that line. Let's go over here. We've got W is greater than or equal to negative 10. So we'll do negative 11, -10, -9, -8, -7. I'm going to put my circle above -10. It is an equals to, so we're going to fill in that circle. And W is greater than or equal to -10. So greater than -10 is headed this way towards the 0, right? Here we were getting away from the 0 because it was less than -6. Here we're going to move our arrow closer to the 0 because it's greater than -10. And of course, the pointer, the alligator, the back of the alligator's head matches up with the pointer of the direction of the line. So now you're going to try a couple of these on your own before we move into decimals. All right, have fun.